So to start out with, okay, with this trip with the bear chasing the deer, okay, we want to break it up into its individual parts first. Okay, so they told us that the first part of this chase, the bear is chasing the deer at 20 meters per second north, and direction's important here, okay, for 185 meters. All right, so that's what we know for part one. Okay, then the bear falls down. Okay, and the deer turns, runs past it. So the bear chases the deer another 83 meters south. All right, so now we have another displacement, 83 meters south. Okay, before catching it 9.48 seconds later. All right, what's the average velocity of the bear? All right, if I want to get the average velocity of the bear, I need the total displacement and the total time. Okay, right now I can get the total displacement because I know how far the bear went in both parts of this chase. Okay, he went 185 meters north and then came back 83 meters south. So the total displacement is 102 meters north. Okay, so I have the top part of that. What I don't have right now is the total time. So I've got to find the time for part one. So for right now, guys, mark-wise, give them 1 mark for having givens written down. Okay, they wrote down some givens because I always tell you, write down your givens. Okay, that's a mark. Next step is I've got to find the time for part one. So T equals D over V. Okay, so we're going to go 185 over 20. Okay, so we've got 9.25 seconds for this first section of the chase. All right, so they can get a mark for this step as well. Okay, they don't necessarily have to have gotten the right answer. That's a method mark. So if they made a calculation error, but they have that written down, they can still get that mark. Okay. In fact, I'm going to give 2 marks here. 1 mark for the manipulation of V equals D over T, and 1 mark for the numbers being plugged in. Okay. Now, on this end here, okay, we're going to have that V equals total displacement, so we're up to 3 marks here, okay, over total time, so that's going to be 9.25 plus 9.48 for 18.73 seconds. Okay, give them a mark if they've got that, okay, because that's their final calculation. That'll give us the average velocity of the bear over the entire trip. All right, so we're going to take 102 meters north, the total displacement, and divide that by the total time, 18.73 seconds. And we're going to get that the average velocity of the bear is 5.4 meters per second north. They must have both the units and the direction on that answer, or it's wrong. Okay, it's not half off because I don't give half marks. Either they got the entire answer right or they got it wrong. Okay, so they've got to have 5.4. If they had 5.44, I'm okay with that because I haven't gone over significant digits yet. Okay, but it's got to have meters per second and north on it. All right, so that one there is out of 5 marks. Questions on number 1? Okay. All right, for our graph here, okay, it's the velocity versus time graph. So if I'm going to find the displacement, I need to find average velocity times time for each kind of section of the graph. In other words, the area underneath the line. All right, so our first calculation is going to be for the displacement during this part of the graph where the object is actually accelerating. And you'll notice here the units are different on this picture for some reason than they were on the other. That makes a bit of a difference. Okay, they were seconds on your question. All right, so the base of this triangle is 10 seconds. The height of this triangle is 60, so 10 times 60 is 300. Yeah, 600, sorry, divided by 2 is 300. Got ahead of myself. Okay, so this one here is 300 meters. Right? Everybody okay with that so far? Okay, 1 mark if they've got that. Then we've got this rectangle that we need to calculate the area of. It's 5 seconds long by 60 high. That's also 300 meters. Give them a mark for that. Then we've got this triangle here. Okay, this triangle is 15 seconds on the base and 60 high. That one I'm not going to do in my head. All right, so our 450 in there. Give them 1 mark for that one. Then I've got this triangle that is 10 seconds on the base and negative 40 high. All right, so that means this is negative 200 meters. And then we've got this triangle here that's 15 seconds on the base and negative 40 high. All right, so that's going to be negative 300. All right, so they get 1 mark for each of the shapes. What do I have to do with all of those? Yeah, as long if they've got it there, right? If they've got 500 for this section, that's fine. Okay. Okay, any other questions so far? What do I have to do with all those numbers? I've got to add them up, keeping the negatives negative because displacement's a vector quantity. All right, so our total displacement for our 6th and final mark here, right? We're going to have 1,050 on the positive side, and we're going to be subtracting 500. Okay, so we're going to have, whoop, not 500. So we're going to have 550 as our total displacement there. Okay. And that's going to be positive because they didn't tell us anything else. Okay. So that's your 6th and final mark for that question there. All right, any other questions on those? Give them a mark out of 11 at the top of the page, please. Hand it back to them so they can see it. And then I would like them in a nice, neat pile on this desk right here.